Assalamu alaikum everyone. Can you hear me?
Assalamu alaikum,
Yes, sir.
sir. Yes, sir.
Okay. So how was your mid exam?
Okay, sir.
Okay, all right. So it is already 10:40. Do you remember anything at all? Whatever we discussed before mid?
Yes, sir.
Not much, sir.
At least do you remember the terms like flags, then overflow flags?
Yes, sir.
What else? Registers.
Yes, sir.
All these things you remember, right? That is more than enough.
Yes, sir.
Actually, the thing that we'll be covering today is pretty simple. There is nothing complicated at all, and most probably it will finish very fast. Okay, but nevertheless, if you face any type of difficulty while understanding, please make sure you ask me. Okay.
Yes, sir.
Okay, sir.
Okay. So let's start. Okay. Can you see my screen?
Yes, sir.
Yes, sir.
Okay. Fine. So this is your lab 6. Mainly today we'll be learning about logic, shift, and rotate instructions. That's all. So before I enter, let me know whether are you guys familiar with AND or XOR operations? Are you guys familiar with these things?
Yes, sir.
Yes, sir.
Very good.
Yes, sir.
This is nothing complicated at all. So this is your first slide, as you can see. So just I have taken two variables a, b, which might have different values like 0, 0, 0, 1, 1, 0, or 1, 1, and I have done AND or XOR and NOT. Is there anything I need to explain over here? I mean, you can ask, definitely, obviously you can ask. But these are the few things you need to remember very thoroughly. That is, what is A and B, what is A or B, what is A XOR B, and what is not A. Do I need to explain?
No, sir.
No, sir.
It is clear, right, to all of you?
Yes, sir.
Okay, so then let's move
Yes,
forward.
sir.
Let's move forward. So the next thing is all these operations can be done in your microprocessor, okay, 8086. So the syntax is very simple. First of all, you provide the operation that you want to execute, like AND or XOR, whatever you want. Then you will provide the destination first of all, then you will provide the source. So once you provide this, there will be AND operation between your destination and source, and the result will be stored in destination. You already know all these things. There is one slight limitation, like memory to memory operations are not allowed. Okay, this is the limitation. But you can have like register to memory, memory to register, or constant with register, and all these things are okay. No problem with that. Is it okay in this slide? Everything clear? We will see examples. Don't worry. We will see a lot of examples. Okay. Moving forward, these are the effects on flags, like your sign flag, zero flag, and parity flag will be affected. So this is actually okay. Just a second. Okay, this is actually quite understandable. Like your sign flag, if you remember, it depends on MSB. Do you remember?
Yes,
Sign
sir.
flag. So sign flag will be affected because your MSB will be affected by your AND or XOR operation. Next comes zero flag. This will also be affected because whatever result you get will be stored in your destination. So if the destination is 0, then zero flag will be 1, or else zero flag will remain 0, right? Then comes your parity flag. If you remember, parity counts the number of ones. If the number of ones are even, parity flag will be 1, otherwise 0, right? So this is how these three flags will be affected. Your auxiliary flag will remain undefined, and in this case your overflow and carry flag will remain 0. Definitely it will remain 0, because if you perform AND or and XOR operation, you are not going either in carry or in case of overflow, isn't it? So in all these cases, your carry and overflow flag will remain 0, and only these three flags will be affected. All right?
Yes, sir.
Okay, let's move forward.
Sir, in the operation, the result is either 1 or 0, right?
Exactly, the result is either 1 or 0.
So how then
okay.
SF will be affected?
Robil, bol
If I want to add one thing,
bol.
actually here things will be on bitwise operation, obviously. So just to make sure that you have understood this part, if your destination and source are, let us say, AH and AL or AH and DL, so those are 8-bit registers. So the first bit, second bit, third bit, this is a bitwise operation. So AND will be for first bit and first bit, AND will be for second bit and second bit of source and destination respectively. Have you understood? So this is just to make sure that you have understood this part. This is a bitwise operation. So the final result will be 8 bit if your source and destination are of 8 bits. Is it clear?
Yes, sir.
Exactly. If you remember your previous classes, we already discussed this, that everything your microprocessor performs are on bits. So all these operations will be performed on bits. Is it okay? Don't worry, the examples will come. Things will get much clearer. For the timing, these are the effects on flag.
Yes, sir.
Now a new concept is mask. This is what a small thing that you need to understand. Okay, that what is mask. Okay. So look at these two. Look at just this AND operation for the time being. See, your B might contain either 0 or 1. It is written at the end. Your B might contain either 0 and 1. So see, if the value of your B over here is 0, and if you perform 0 and 1, you will end up getting 0. If your B is 1, and if you perform 1 and 1, again you will end up getting 1. That's why it is saying that with B, if you provide 1 bit with AND operation, you will always end up getting the exactly same bit. And with B, if you perform your AND operation with 0, you will always get 0 irrespective of the value of B. See, if B is 0 over here, 0 and 0 is 0. If B is 1 over here, 1 and 0 is also 0. So whatever is the value of B, you will always end up getting 0. Is this portion clear? AND portion.
Yes, sir.
So this thing over here that we are writing, this is basically known as your mask. For this particular example, your mask is a single bit, but your mask can be 4 bit, 6 bit, 8 bit, whatever. Your mask can be of any bits, but this thing is known as mask. Now come over here, see, a 0 mask bit clears the corresponding destination. This is for your this one. So if you provide 0 and provide AND, it will clear the corresponding destination. Clear means it will become 0 irrespective of the value of B. And if you provide 1, then your bit will preserve the corresponding destination bit. Exactly this thing. If you provide mask of 1 with AND operation, whatever was your original bit, it will preserve that original bit. Is this portion understood?
Yes, sir.
So now go to the same thing for OR. The same thing. See, with OR, if you provide 0, it will preserve the bit. And with OR, if you provide 1, it will set the bit to 1. The same thing is written over here. A 1 must bit sets, that is makes 1, the corresponding destination bit, and a 0 must bit preserves the corresponding destination bit. Similarly, as similar to A, but there is slight differences. Like in case of AND, your 1 bit preserves the destination bit. And in OR operation, your 0 bit or 0 mask will preserve the destination bit. Is it okay?
Yes, sir.
Okay. Just a second. Okay, Arifin, Rabbi, you are getting disconnected. Okay, I get that. So don't worry, in the next lab, it will be recorded and you will be provided the recording. For the time being, just concentrate how much you can. Okay, so the last one is XOR operation. So see, B can be either 0 or 1. So if you perform 0 XOR 0, you will get 0 because 0 XOR 0 is 0. And if you perform 1 XOR 0, you will end up getting 1. So you see, with 0 as mask, if you perform XOR operation, then this one preserves your original bit. Now come over here. If the value of B is 0, and if you perform 0 XOR 1, you will get 1. If the value of B is 1, and if you perform 1 XOR 1, you will get 0. So you see, your corresponding bits are complemented or reversed. So that's why B XOR 1 will complement the bit. So that's why it says a 1 mask bit complements the corresponding destination bit, and a 0 mask bit will preserve the corresponding destination bit. Is it understood up to this? Any question?
No, sir.
From the voices, I can understand that maybe only 2 or 3 of you are responding. The others, if you are not responding and if you have understood, that is fine.
Explain the Zord once again.
Okay, Zor, 1 second. All right. So, first of all, tell me what is 0 Zor 0? What is 0 Zor 0?
That should be zero. So that should be zero.
Exactly. 0 Zor 0 is 0. What is 0 Zor 1?
That would be one.
1. Let us go now vice versa. 1 Zor 0 is
One.
1 and 1 Zor 1 is
Zero.
0. Exactly. Now you see, in this case, your B can be either 0 or 1. So if you perform 0 Zor 0, so 0 Zor 0, you will get 0, isn't it? So if your B is 0, your output is also 0. If you perform 1 Zor 0, this one, 1 Zor 0, you end up getting 1. So if you provide 0, you get 0. If you provide 1, you get 1. So if you provide a mask of 0 with Zor operation, you will end up getting the exactly same bit. That's why it says a 0 mask bit preserves the corresponding destination bit. Now come to the next one. B can be 0 or 1. So first of all, let B be 0. So 0 Zor 1 is how much? 0 Zor 1 is 1. So if you provide 0, you are getting 1. Now B can also be 1. So 1 Zor 1. So 1 Zor 1 is 0. So 1 Zor 1 is you are getting 0. So if you provide 0 with a mask of 1 with Zor operation, you get 1. And if you provide 1, you get 0. So that's why it says a 1 mask bit complements the corresponding destination bit. Is it understood now?
Yes, sir. Okay.
All right. If you have understood, so let's move on to the next one. Okay, so this is the example, first example. So look at the question. The question says, clear the sign bit. If you remember, clear means make 0. So clear the sign bit of AL while leaving the other bits unchanged. So your solution is use AND with what? This is the question, as the mask. So this will be counted as your class performance. And let me ask, wait. Do we have ID 91, Kais? Do we have ID 91, Kais?
Yes, sir.
Okay, Kais, can you give me the answer?
So this example.
Yeah, example. I will help you. Don't worry, Kais. I will help you. So you see, we need to clear the sign bit of AL. If you remember, your AL is 8 bit, right? So there will be total 8 bits. So 1, 2, 3, 4, 5, 6, 7, and 8. So what you need to do, this is your sign bit, right? Your MSB. This is basically your MSB or your sign bit, whatever you say. So you need to make sure that this one will be 0 while the other bits will remain as it is. So your answer is we have to use AND operation, but with this AND operation, what will be the mask? So please tell me the answer. You can give your answer either in binary or hexa or decimal. It is up to you, totally up to you. Just give me the answer. Can you answer?
Sorry, sir. I'm not good.
Okay.
I try.
What is your ID?
34.
34, Muntasir. 34. Okay, I think you can try. Say.
So the MSB will be 0 and the rest of them will be 1.
It will be 0 and the rest will be
1.
1. Okay, is there anyone who think the answer he gave is wrong?
No, sir.
Okay, whoever gave the answer 34, Muntasir, please explain
Yes,
why
sir.
you gave this answer.
So because, sir, if I take we know in case of AND gate, we get if the values are similar to the mask, if the values of the bits are similar to the mask, only then we will get the value we desire. So if we take the value of the MSB as 0, and in case the mask value is also 0, so 0 and 0, it will never give us the desired value. But in case the values of the second, since the second to the last bits all are 1, and if also we have the mask value as 1, so 1 and 1 will give our output as usually 1, which is unchanged.
Okay. Your simpler answer is a 1 bit mask will preserve and a 0 bit mask will clear, isn't it?
Yes, sir. Yes, sir.
Okay, so if you convert that into hexadecimal, what will we get? Okay, fine. It will be 7F. Okay,
7F, sir.
don't worry. Okay, wait. Okay. So is it understood, everyone?
Yes, sir.
Yes, sir.
So okay. So look at the next question now. Change the sign bit of dx. Now, if you remember, your dx is a 16-bit register, right? Your dx is 16-bit register, and your solution is we have to use XOR. But the question is, what is the mask? So we need to change the sign bit. Again, the same. The MSB will be changed. Rest of the bits will be preserved. And we want to perform XOR operation. And I want this answer from, do we have ID 141, Samadul? 141, Samadul. Are you there?
সম্ভবত নাই, 141 প্রেজেন্ট না।
সামাদুল এই নিয়ে 3বার ডাকলাম, রবিউল এটা একটু মার্ক করতো। সামাদুল আমি এই পর্যন্ত কোনোবার ওরে পাই নাই, প্রতিবারই অ্যাবসেন্ট। ওকে, নেক্সট আইডি 155, রায়হান, আর ইউ দেয়ার? 155, রায়হান।
Yes, sir.
Can you give me the answer?
আচ্ছা, 141 লাস্ট 3টা ক্লাসে ছিল না, প্রথম 2টাতে মনে হয় ছিল।
আমার এখানে তো আমি র্যান্ডমলি ডাকি তো কোন ল্যাবে, আমি ওকে 3বার ডাকছি, 3বারের একদিনে আমি ওরা পাই নাই আর কি। আজকে নিয়ে 3rd টাইম ডাকলাম আর কি। ওকে রায়হান, সো ক্যান ইউ গিভ মি দ্য আনসার? Come on, either yes or no. If yes, you can try.
So the first one will be 1, the rest of the thing will be 0.
Okay, so you are saying for XOR the first one will be 1 and the rest will be 0. Can you explain me why? You need to explain why. Tell me why you gave the first one as 1. Tell me this one. Why you are giving the first one as 1? You can ask me to move along slides and everything. Everything is up to you. You can ask me to do anything. But I need you to explain me why you told that the first one is 1.
Okay, sir.
If you can't explain, you are not going to get the marks. Come on, Samadul, sorry, Raihan, if you have given me the answer, you definitely know why you have told this thing. So tell me why.
So actually the
all right, I think I will move on to
can I try, sir?
Sir, 149.
no, not 149. আর কি ছিল?
16 batch 35, sir.
15 batch 35.
16
no.
batch.
Sorry, 16 batch 35. No, for the time being, no.
103.
103. This is rather a very easy question. Okay, 103. Akash, okay, tell me why.
In XOR operation, if we use the mask of 1, then we get the bit changed.
Okay.
So that's why the first will be 1.
Okay, and 0. And why 0?
Because those bits would not be changed. So I don't know it exactly.
You don't know exactly.
I know about the 1, but rest of the zeros I cannot say exactly.
Okay, fine. Anyway, I'll take your answer. So let me go to the previous slide. See what happens with XOR operation. If you provide 1, it complements the bit. That was your explanation. That is correct. You need to provide 1. and for preserving the bit you need 0. So that's why the answer is 1 and rest of them will be 0. So if you convert that, you will get 8000H. So your answer will basically be, okay, wait, your answer is actually right. So answer will be 1, and then there will be 15 zeros actually. So 1 and then 15 zeros is basically your 80008. Is it okay?
Yes,
Everyone,
sir.
is it understood? The
Yes,
mask
sir.
operation and all these things? Okay.
স্যার আমি যদি স্যার উল্টা মাস ধরে করি স্যার, আমি যদি মাসটাকে 0 ধরে করি স্যার, মানে
Mask.
উল্টা, মানে এখানে তো স্যার ও যেটা বলছে স্যার মাসটা 1 ধরে করে বাকি সবটা চেঞ্জ করে নিছে স্যার। But if I take the mask as 0 and if I need to change the value of the MSB, so I need to take the value of MSB as 1 and the rest of them is 0 sir. So that's also an option.
বুঝিনি, তোমার আনসার আবার বলো, তুমি কি, তোমার মাস কত হবে? হোয়াট উইল বি ইওর মাস? টেল মি।
আমি যদি স্যার আমার মাসটা স্যার 1 ধরে করি স্যার, ঠিক আছে, আমার মাসটা 1 ধরে করলাম, তাহলে আর আমি যদি আমার এমএসবি টা 0 ধরি এন্ড আমার বাকি সবকটা বিট 1 ধরি স্যার, তাহলে তো স্যার অ্যানসারটা ঠিক আসছে।
ও সব 0 ধরবা, আর 1 কোন জায়গায় থাকবে? এমএসবি তে না এলএসবি তে?
স্যার আমার এমএসবি তে 0 আর বাকি সব 1।
আচ্ছা, এমএসবি তে 0 বাকি সব 1।
ইয়েস স্যার।
আর তুমি কি পারফর্ম করবা? জ্বর?
ইয়েস স্যার।
এখন তুমি যদি জ্বর পারফর্ম করো, আমাকে বলো, যদি 0 থাকে, তোমার মাস্কে যদি 0 থাকে, তাহলে তোমার অরিজিনাল বিট প্রিজার্ভ হয় নাকি কমপ্লিমেন্ট হয়?
ও প্রিজার্ভ হয় স্যার।
হ্যাঁ, তাহলে কি তোমার এমএসবি চেঞ্জ হচ্ছে?
ও না স্যার, না স্যার।
আর বাকিগুলো কি সব রিভার্স হয়ে যাচ্ছে না?
ইয়েস স্যার।
তাহলে তো উল্টা হয়ে গেল কাজটা।
ইয়েস স্যার, ইয়েস স্যার।
বুঝা গেছে?
ইয়েস স্যার, বুঝছি স্যার।
Okay. Okay, so let's move on. All right, so this is another test instruction. This is also very straightforward. I mean, nothing complicated over here. So test instruction performs the same thing as AND. The only difference is that your destination will remain unchanged. That is the only difference. Like if you perform AND with, okay, let me cut this. So if you perform AND with your destination and source, then this instruction performs AND between them and stores the result in destination. But in test, if you perform test destination and source, then it will perform the test operation, but your destination will remain unchanged. Is it okay?
Yes, sir.
Now you guys might be a bit confused, then what is the purpose of this test, isn't it? Because the destination is not changing. So you see in the next slide. So you see the question is jump to level below. So jump to level below if AL contains an even number. How do you determine whether AL contains an even number or odd number? Tell me. How do you know?
Sir, with the LSB.
Exactly, with LSB. So this is your LSB, right? So if your LSB is 0, then the number is what? Odd or even?
Even.
Even.
Exactly. And if it is 1, your number is odd, isn't it?
Yes, sir.
So as I said, so see what test is doing. Test and your mask is 1. So it is performing an AND operation with AL. So whatever are the values of AL, with all of those values you are performing AND operation with 1. I mean 1 is what? 1 is 0 0 0 0 1 2 3 4 5 6 7 and 1. So you are performing AND operation with this mask, isn't it? So what happens if you provide 0 with AND? Tell me, it preserves or it changes? What happens?
It goes to 0.
Exactly. So all of these values will definitely be 0. The only remaining is 1. So you see, if your number is even, that is 0, what will you get over here?
0.
Exactly, you will get 0. If your number is odd, what will you get over here?
1.
Exactly, you will get 1. So you see, it will perform your AND operation, and next condition is jump if 0. If you remember, your 0 flags will be affected. So jump if 0. So if your result is 0, then your 0 flag will become 1. Otherwise, your zero flag will become 0. So your zero flag will only become 1 if the LSB contains 0, and that is what makes it an even number. In that case, if you perform test, your result will all be 0 and your zero flag will be 1, and thus you will jump. But if your LSB is 1, that is, it is an odd number, then your result will be 0 0 0 0 0 0 1. So this is not a 0 number, so your zero flag will be 0 and this jump will not be performed. Is it understood now?
Yes, sir.
Everyone, is it clear?
স্যার আরেকবার বুঝাইলে ভালো হয় স্যার।
আর একবার বুঝালে ভালো হয়। Okay, so you see, the difference between test and AND is that if you write test then AL and 1, then the values or the contents of AL will not be changed. So whatever is the value of AL, and 2 3 4 5 6 7 8, okay, so say the value of AL is something like this, 0 0 1, something like this. Say this is your AL. So whatever is the value of your AL, you are performing AND operation with a 1 mask. So if you see, this is basically your 1. I mean, this 1, if you do not provide anything, this is basically in decimal, right? So if you convert this 1 into binary, you will get 7 zeros first and then 1. So this is basically your 1. Okay, can you listen?
Yes, sir.
Are you listening?
Yes, sir.
Hello.
Sir, your voice sometimes it's unclear, but
It's distorted, sir.
Okay.
it's okay, sir. No.
Okay. All right. So that's what I was saying. So say AL contains any value, something like, okay. Yeah. I know. I'm actually in my village.
স্যার কথা কিছু বোঝা যাচ্ছে না স্যার।
So you'll have to bear with me. I'll repeat. All right. So let AL contain this value. It might be any value. All we are interested is in this LSB. That is the last. Our mask is 1. Okay. Okay. Can you listen now?
No, sir, not clearly.
Sir, still it is distorted, sir.
Hello.
Yes, sir. We can hear now, sir. Hello.
All right. Yeah. Can you hear now?
Yes, sir.
Can you hear?
Yes, sir.
Yes, sir, we can hear you.
Okay. All right. So as I was saying, okay. So say your AL contains this value. I mean, your AL may contain any value. We are only interested in the LSB of AL. So say this is the LSB for the time being, and you see 1 is your mask. So if you convert this 1 into binary, you will get this one. I mean, this is your mask basically. So see, now if you perform AND operation with this AL, for all of these 0, whatever is the value of your AL, irrespective of all those values, you will get all of them to be 0. Isn't it? Because if you perform AND operation with 0, you will always end up getting 0. Now look at this LSB. If your LSB is 0 and you are performing AND operation with 1, you will get 0. So if your LSB is 0, you are getting 0. But if your LSB is actually 1, and if you perform AND operation with 1, you will end up getting 1. So that means you are clearing all your bits except your LSB, and you are preserving your LSB. So if you preserve your LSB and your LSB is 0, that means the result of this test operation will be 0. So if the result is 0, your zero flag will be 1. But since you are preserving the LSB, if the number is odd, that is there is 1 in the LSB, then your result will be this one, that is non-zero. So if the result is non-zero, then your zero flag will be 0. So now you see, if your zero flag is 1, in that case this condition becomes true. This is a jump, if you remember from your previous classes. This is conditional jump. So the condition for this jump is your zero flag should be 1. That means the result should be 0. So if your zero flag is 1, only then you will jump in this level. Otherwise you will not jump in the level. Is it understood now?
Sir, is it the only criterion for jump, sir?
No. This is the only criteria for jump 0. There are many other jumps. For jump 0, we only check the zero flag, nothing else.
Okay, sir.
Okay, you can see your previous class, then maybe you forgot. There are a lot of conditional jumps. Jump 0 is one of the conditional jumps. All right?
Yes, sir.
Okay, can I move on?
Yes, sir.
All right, next one. Fine, now these things are simply shifting. So these are actually rather much simpler now. If you understood mask, these are nothing. So you see SHL, this is basically your shift left instruction. So what it does, it shifts the bits in the destination to the left. That is the only thing. So if your syntax is say shift HL destination comma 1, then in your destination all of your bits will be shifted to your left. So see the figure, if all the bits are shifted to your left, your LSB becomes empty. So another 0 comes to the LSB, and from your MSB, this is your MSB, whatever bit was there in the MSB, it goes to the carry flag. So this is your shift left instruction. So see the last one, R0 is shifted into the rightmost bit position and the MSB is shifted into carry flag. Is it understood? Shift left instruction.
Yes, sir.
Very
So
simple.
what does the 1 signify in the command?
The 1 means there will be one left shift. I mean one time, only once all these things will be shifted.
Okay, sir.
All right. Okay, we'll see the example, don't worry. So this is an example, okay? So see, suppose DH contains 8AH. Okay. So 8AH, so actually 8AH, this hex, if you convert into binary, this is what you get, okay? 1 0 0 0 1 0 1 0. This is your binary form of 8AH. And CL contains 3. Okay. Before that, just look at this portion. In the previous example, in the previous slide, I told you about only one single shift. But if you want multiple shifts, then the number of shifts that you want will always be stored in CL. So that's why it says that CL contains 3. And you see the instruction is shift left DH comma CL. That means you want 3 shifts, not a single shift. If you have targeted for a single shift, instead of CL, you could have written 1. But if you want more than one shift, then that particular value should be stored in CL only. Is it okay?
Yes, sir.
Okay. So see this, say this is the thing. Now DH contains this and this is your carry flag. Okay, let's see. So say this is your carry flag. So after first shift, what will be the value of carry flag? Tell me.
1.
Exactly, it will be 1. And what will be the value of DH?
0.
0, sir.
0 then?
0 0 0 1 0 1 0 0
0 0 0 1 0 1 0 then?
0.
Exactly. So see the, okay, let me erase these portions. So your carry flag was supposed to be 1. So you see your carry is 1 and the rest, whatever you have given the answer, check. Did you get the exact same thing? 0 is
sir.
added at the last, and so now you go for second shift. So after the second shift, what will be the value of carry flag? Now?
0.
0.
Exactly. Carry flag will be 0. And what will be these values?
0 0 1
1,
0
0,
1 0 0 0.
Exactly. See, your carry flag is now 0 and you are getting 0 0 1 0 1 0 0 0. So after the final shift, the value will be 0 and then 0 1 0 is okay. So if you convert that into hex, your answer will be carry flag contains 0 and DH contains 50H. I mean, 50H is the hex form of this binary form. Is it understood? Now, did you understand shift left?
Yes, sir.
Clear, everyone?
Yes, sir.
Okay. So let's move. As I said, today's one is very simple. Nothing complicated. All right, here is something else, like shift left is actually equivalent to multiplying as well. So you see that it multiplies by 2. Look at the example. Say AL contains 5. For the binary form of 5 is this one, 101B. You know that if you perform a left shift, a 0 will be appended at the rightmost bit. So your result will be this one. So you convert that into decimal, you get 10. So a left shift is equivalent to multiplying your destination by 2. The same thing, if you perform another left shift over here, you will get this one. And that is basically your 20D. So you are multiplying 10 with 2. Is it okay? So a left shift on binary actually multiplies it by 2. Is it understood up to this?
Yes, sir.
Yes, sir. Yes, sir.
Rather very simple, okay? Okay, moving forward. Now this is another, that is shift arithmetic left. Basically your SHL, that is shift left, and shift arithmetic left, both of them generate the same machine code, meaning that both your SAL and SHL will give you the exactly same result. There is no difference in the result. But why we need this one is that sometimes you need to perform shift operation to only shift the bits. Okay, that is your main target. You need to shift your bits. And sometimes you perform the shift operation to multiply. So when you are interested in multiply, to make it understandable to rest of the people or rest of the readers, you basically use SAL. But even instead of SAL, if you use SHL, it will give you the exactly same result. So you see it says over here, to emphasize the arithmetic nature of the operation, the opcode SAL is used. That is the only difference. The same thing, SAL and SHL, both are same. Is it okay?
Yes, sir.
Yes, sir.
You'll get the exactly same thing. See, where numeric multiplication is intended, over there you will use SL, otherwise you will use SHL. Okay, let's look at an example. Now look at this example first of all, carefully, okay? So come to the code, don't see the output now, come to the code. So in BX, we are having FFFFH. So now see this converter. So FFFFH, in unsigned it is 65535, but in signed it is -1. Now in CL we are putting 3. So if we perform shift arithmetic left with BX and CL, that means we are multiplying our destination by how much? Tell me. You are multiplying your destination by how much?
6.
Is it 6? You are
2 cube, 8.
8, sir.
Exactly. 2 into 2 into 2. That means you are multiplying your destination by 8. So you see, this is your maximum, isn't it? So if you multiply it by 8, your result will not be stored over here. So we are interested in this signed operation. So if you multiply -1 with 8, what should be your result?
-8.
-8. So now you see, this is in BX. Now look at this BX over here. Your BX is FFF8. If you convert that, you will see this is equivalent to -8. So you get the exactly same result. Is it understood? Shift arithmetic left. I mean, even instead of this SAL, you could have used SHL. No problem with that. You would have ended up with the exact same result. So is it, I mean, this is all about your multiplication and all. By shifting, you are multiplying. That's it. Is it understood now, up to this?
Yes, sir.
Is there anything complicated up to this?
No, sir.
Okay, alhamdulillah. So let's move on. So the next thing is right shift. Exactly the opposite of left shift. A0 will be shifted into the MSB, and from the LSB, the bit will be carried to the carry flag. That's it. That is your right shift. The destination is same, everything is same, just the opposite one. Clear, right shift?
Yes, sir.
Yes, sir.
Anything over here you want me to explain in right shift? If you understood the left
No,
shift,
sir.
right shift is nothing, exactly the opposite one. So let's look at an example over here, if you understood. Okay, so let me have someone to answer this. Okay, do we have ID? Okay, do you have ID 118? Fariha, are you there?
Yes, sir.
Okay, so help me find the solution of this. Okay, so suppose DH contains 8AH. Okay, so let me help you. So let me provide you the binary form of 8AH. Okay, so 8AH. So tell me, what is the binary form? Okay, you should be able to tell me what is the binary form of 8AH.
1000. 130.
1000, then
1010.
1010, exactly. So this is your 8AH and Cl contains 2. Fine. What are the values of DH and CF after the instruction shift right DHCF? Okay. So let this be your DH, and let this over here we have our carry flag. So how many shifts will be there? Tell me.
2 shifts.
2 shifts. Okay. So after the first shift, what will be the value of carry flag? Tell me.
0.
Okay, 0. And what will be the value of DH?
It will. So should I say from the?
Yeah. Say from the right. It becomes easier for you.
101.
Okay.
000. 10.
Okay, 10. So this is you get after the
First shift.
first shift. So there will be total 2 shift. So after second shift, what will be the value of carry flag?
1.
Okay, 1. And what will be this value?
010.
0 1 0 0 0 1
100.
1. Okay, 0 0. Right? This one.
Yes, sir.
So what is the hex form of this one?
It is 2. So it will be 2 2.
22H, and this one will be 1. So let's see the answer. The answer is your carry flag contains 1 and your DH contains 22H. So is it understood to everyone?
Yes, sir.
Clear?
Yes, sir.
Okay, so can I move forward?
Yes.
All right.
Yes, sir.
Now see. So there is a slight difference now. This is your shift arithmetic right, but there is a slight difference with shift arithmetic left. If you remember, your shift arithmetic left and shift left both were the same thing, but this is not the case for shift arithmetic right and SHR shift right. This is not the same thing. The difference is that your MSB will retain its original position and all other bits will be shifted to the right. So whatever was there in MSB will also be shifted to the right, and it will also be shifted to its own place. That means your MSB will remain same. Rest of the thing is same as your shift right. Is it understood, everyone?
Yes, sir.
Yes, sir.
In case of shift right, a 0 was shifted into the MSB, right? But in shift arithmetic right, whatever was your previous MSB, your MSB will retain its original position, and all other bits will be shifted to the right. Your MSB value will also be shifted to the right, but your MSB will retain its own position. Like that's why from MSB you can see there are 2 arrows. One is moving to the right, another is preserving its own position. Is it understood?
Yes, sir.
Yes, sir.
All right. So this is the only difference. Okay. Now you see, if your shift left can multiply by 2, definitely your shift right can divide it by 2, right?
Yes, sir.
So that is that is what it says. But there is a small thing. Okay. See, for even numbers, a right shift divides the number by 2. So even numbers means, say the number is 16. So a right shift will make it 8. Say your number is 20. A right shift will make it 10, and so on. But if the number is odd, then what will happen? So in that case, a right shift halves it and rounds down to the nearest integer. That means, say you are having 15. So if you right shift it, how much will be your answer? Tell me.
Sir,
8.
How much?
8.
It says rounds down.
7.
7.
Exactly, it will be 7. Say if your number is 13, how much will you get?
6.
6.
Exactly, 6. If your number is 21, how much will you get?
10.
10.
Is it understood? Is it understood, everyone?
Yes, sir.
If the number is even, the answer is pretty straightforward. But if the number is odd, we do not get in decimal, right? In decimal, we normally do not get. So it will round down to the nearest integer. So let's see an example over here. So pretty straightforward. See, in BL we have 5. So we are shifting it by 1. The value of CL is 1. So if we shift it by 1, it will be divided by 2. You will get 2.5. They will round down. So the answer will be 2. You see over here, the answer in BX is 2. Is it okay?
Yes, sir.
Yes, sir.
Any question up to this, you can ask. Okay, if there are no questions, then I think I will move on. All right, so there can be signed and unsigned division. So as you already understood, your shift arithmetic right, this one preserves your MSB. So for this, since shift arithmetic right preserves your MSB, for signed interpretation you will use shift arithmetic right, and for unsigned interpretation you will use shift right, because shift right does not preserve your MSB. So if we want signed interpretation, then we will go for SAR. If we want unsigned interpretation, we will go for shift right. Clear up to this?
Yes, sir.
Can you repeat?
Okay. So if you remember, in your shift arithmetic right, that is in your SAR, your MSB is preserved. I mean, if this is your bit, this is your MSB, then MSB is shifted right. Also, MSB is shifted to its own position. That means this MSB is not affected by your SAR instruction. So if we want signed division or signed interpretation, we want our MSB to remain as it is. So in that case, your SAR will be used. But for unsigned interpretation, our SHR will be used. Is it okay?
Yes, sir.
Okay. So moving forward. All right, this is an example. So the question is, use right shifts to divide the unsigned number by 4. So if we want to divide it by 4, how many shifts do we need? Tell me.
2 shifts.
Exactly, we need 2 shifts. Okay. So this is your answer. See. So the number is 65143. So the number is 65143 that is being stored in BX. Since dividing it by 4 is equivalent to 2, so we are moving CL to 2. So this is an unsigned number. That's why you are using shift HR BXCL. So if you divide 65143 divided by 4, the answer that you get is how much? Tell me. How much do you get? The answer we get is 16285.75. So it is, if it is rounded down, it will be 16285. So this should be your answer. So you see your answer is 3F9D. So if you convert 3F9D, you get unsigned. Yeah, signed is unsigned is 16285. Exactly the same answer. See if you have any question in this slide.
No, sir.
Is it clear, everyone?
Yes, sir.
Yes, sir.
Okay. So let's move. Okay, another example. So this was the example of your unsigned division. Now this is the example of signed division. So BL contains -15, the decimal value of after SAR. So you see SAR, that means this will be signed division and it will be divided by 2. The answer is supposed to be -7. So see, the converter is also given. Sorry, not -7, it will be -8. Extremely sorry. Can anyone tell me why it will be -8? Good question. I was supposed to ask this question anyway. I gave you the answer.
So it's rounding down.
Exactly, it is rounding down. So -15 divided by 2 is basically your -7.5. If you round down, because of this minus sign, this will be -8 and not -7. But if you divide 15 by 2, you will get 7.5. If you round it down, you will get 7. Is it okay?
Yes, sir.
Yes, sir.
All right. Moving on. Okay, so all those were about shift. Now you see, now we are interested in rotate. So almost the same thing. The only difference is now the carry flag comes into play and this forms a complete circle. Like in your shift instruction, a 0 was shifted into the LSB, isn't it? But now, instead of that, whatever was there in your MSB, that thing will go to the carry flag and it will also come to the LSB. Rest of the bits will be shifted to the left by 1. Similar thing. Is it okay?
Yes, sir.
Yes, sir.
So see the syntax and everything. The syntax is rotate left. So rotate left. So destination and 1. If you want multiple rotates, then destination and CL. Can I move on?
Yes, sir.
All right. So this is an example. All right. So let's look at this example. Okay.
ম্যাগির আনতে বলো।
কে ভাই এখনো খাওয়া দাওয়া করেনি সকালে? All right, moving on. So
Sorry, sir.
no problem. Okay. So say BL contains these values, okay? So if you convert that into hex, BL basically contains your 65H. So we have written BL over here. So the question is, what will we get if we execute rotate left BL, 1? So what is our initial carry flag? We don't know. So that's why I've given a question mark. It might be any value. So after one rotate, this 0 will come over here, right?
Yes, sir.
This one will come over here. This one will come over here. This one here. This one here. This one will come over here. This one will come over here. This one will come over here. And this exact 0 will also come over here. Is it understood now?
Yes, sir.
Yes, sir.
So the exact same thing is quoted over here. So we have given 65H, okay, and we have performed one rotate left. The answer we got in BL is CA. So CA is basically your 1 1 0 0 1 0 1 0. So we are getting the exact same answer. Is it okay? See, if you have any question in this slide, these things are rather very easy. Okay, this rotate, shift, and all these things are very easy. So can I move on?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so the same thing. This is right. So do I need to explain anything?
No, sir.
No, sir.
No, sir.
Still, I should say the difference. Okay, so the only difference is that now. So the only difference is that now from LSB it will go to the carry flag, and the value of LSB will move to the MSB. All the bits will be shifted to the right since it is a right operation. Okay.
Yes, sir.
Similar, same thing. So moving forward, okay, this is an example. So look at this example. Now things will get a little might be complicated. Okay, so let's see. Tell me why this line is there, why we are performing XOR AX and AX. Before going to the question, I have asked you this. So why are we performing XOR AX and AX? What will happen?
Sir, it clears X.
It clears.
It becomes 0.
Exactly, your AX becomes 0. So whatever is the value of AX, say the value of AX is 1 0 1 1 1 0 0 0, whatever is the value. So if you do XOR operation with exact same values, if you do XOR operation, you will always get 0, right? So you are performing XOR AX AX, that means you are clearing the register. Now see the question. Use rotate left to count the number of 1 bits in BX. So whatever is there in BX, you need to find out how many 1 bits are there. The condition is without changing BX. The value of BX cannot be changed. And whatever answer you get, you store the answer in AX. That's why initially we are clearing AX. That is, we are making sure that AX is 0. Then we are moving 16 to CX. If you remember from your previous labs, CX is your loop counter. So how many times we want to run the loop? We want to run the loop 16 times. Why we want to run the loop 16 times? Because my BX is a 16-bit register. If I was interested in BL, I would have run the loop for 8 times. But since BX is a 16-bit register, I want to run this loop for 16 times. Now come inside the loop. Okay, rotate left BX comma 1. So whatever is there in your BX, it will be rotated just once. Okay, so I am doing rotate left. So whatever was there in my MSB, that will be moved to the carry flag. Again, I am saying after this line, whatever value was there in the MSB of your BX, that will move to the carry flag. Okay, it will move to the carry flag. Assume the value of BX is something like 0, 0, 1, 0, 1, 1, 1, something like this. Okay, so initially what will be the value of your carry flag? 0, isn't it, for the first one?
Yes, sir.
Yes, sir.
Okay. So now it says jump if no carry. So is there any carry now?
No, sir.
There is no carry. So it will jump over here. That means it will directly come over here. Now loop top. So from here it will again come to this line, and the value of your CX now becomes 15, isn't it? Right?
Yes, sir.
Okay, now again I come over here. Again I perform rotate left BX comma 1. So now tell me, what will be the value of carry flag now?
0.
Exactly. Again the value will be 0. So I will come over here, jump no carry. Since there is no carry, it will directly come over here. And from here again you will jump over here. The value of CX will now be 14. Now again rotate left. I will come over here. Now tell me, what will be the value of carry flag?
1.
Exactly. Now the value of carry will be 1. So jump if no carry. So the condition is false. Now it will come over here. The value of AX will become 1, right?
Yes, sir.
After this again we will come over here. From here again we will go over there, and the process will go on. So you see, only when you encounter 1, your this line is being executed. So if there are 5 ones, this line will be executed 5 times, so the value of AX will be 5. So the number of ones will be the number of times you execute this line. So AX will contain the number of ones. So let me know whether you understood this portion or not.
Sir, can you please repeat, sir, one time?
Allah, purata abar.
Sir, not the whole one.
Kunta
Sir,
bolo.
from the jump if not carry, sir. If
Acha. Jump if not carry. Okay. Still. Okay, I'm explaining. See, assume this is your BX. Okay, just assume. So it becomes easier to understand. Assume this is your BX. Okay, these values. So when you are over here for the first time, what you are doing? Rotate left BX comma 1. So that means all of these bits will be rotated left 1 time, isn't it?
yes, sir.
This is your MSB, right?
Yes, sir.
So this will move to the carry flag, right?
Yes, sir.
All right. So now after this line, your carry flag contains 0, and your, let's set BX over here. Your BX will be 0, 1, 0, 1, 1, 1. After this, whatever is there, this is rotated, so 0 will come over here. I mean, this 0 will come over here, isn't it?
Yes, sir. In the LSB, sir.
Okay. So now you see the condition is jump if no carry. In carry flag, what is the value?
Sir, 1, sir.
Is it 1? See.
So no, sir. Now 0. Now it's 0.
Now 0, right? So
Yes,
it
sir.
says if there is no carry means 0. So since there is no carry, it will directly come over here in the loop, right?
Yes, sir. Yes, sir.
So it will, from here it will go to loop top. So again it will come over here. In the next instance, your carry, this is your MSB. So carry flag will again contain 0, and your BX will contain 1, 0, 1, 1, 1, 0 and 0, right?
Yes, sir.
So again the carry is 0, so it will come over here in your loop and it will go over there. Now in the third case, your MSB is 1. So what will be
Yes,
the
sir.
value of carry?
Sir, 1, sir.
It will be 1, and your BX will be 0, 1, 1, 1, 0, 0, 1, right?
Yes, sir.
This will be your BX. Now come over here. The condition says jump if no carry. But what is the value of carry flag now?
1, sir.
1. That means there is carry. So if there is carry, this condition becomes false, so it will not jump. If it does not jump, it will come to the next line, right?
Yes, sir.
In the next line, you will increment your ax by 1. So initially the value of ax was 0. Now the value of ax will be 1. After this line, you will come over here. Now again loop top. So again you will jump over here. So again, if you get 0, now you get the scenario. If you get 0 in carry flag, you will come over here. But if you get 1, you will come over here. So if there are 5 ones or 6 ones, for all those 5 or 6 times, you will execute this particular line. So every time it will increment by 1 and your AX will contain the number of 1 bits in BX register. Is it
Yes.
understood now?
Yes, sir.
Everyone, is it clear?
Yes, sir.
All right. Only a few things are remaining. Let's move forward.
Sir, I have a question.
Yeah, sure. Bolo.
Sir, if we just directly move 0 to AX, is there any problem?
You want to move 0 to... Oh, okay. You are talking about this line, particular ZOR.
Yes, sir.
Yeah, you can move directly 0. You can move 0 directly to X. No problem with that.
Okay. Thank you.
At the end of the lab, I will explain you why we did all these things. I mean, at the end, whatever question you ask, there is a separate answer. Okay, I will give you the answer at the end. Okay, not now. Let's keep on going. Okay, so far the instruction was only rotate, RO. Now there is a slight difference. Now it says RCL. That means you are including carry. So meaning is that in the previous example, for rotate left, your MSB shifted to your LSB, right? Now your MSB will go to the carry flag, and whatever the value was there of the carry flag, that will go to the LSB. That is the only difference. So say initially your carry flag was 1, and say this is 0 1 0 1 1 0 1 0, something like this. Say this was the case. After rotate carry, this 1 will come over here. So this one will become 1, and this 0 will come over here, and all this will be shifted left. So your number will be 1 0 1 1 0 1 0. Did you get the scenario? This is your original value, and this is the value you get after 1 RCL. This is your initial carry. So this initial carry will come over here. This will be your whatever was there in your carry flag, that will go to the LSB. Whatever was there in your MSB, it will come to the carry flag. So this is now your present value of carry flag. So let me know whether you understood this one or not.
Yes, sir. Understood.
Everyone, did you understand? Because this is also very simple.
Yes, sir.
So whatever was stored in the previous value of carry flag will just go to the LSB.
Exactly, that is the only difference. Whatever was there in the previous value of carry flag, that will be shifted into the LSB. Okay, let's see. So this is rotate carry right, exactly the opposite. So whatever was there in carry flag, now it will move to the MSB. That is the only difference. And from LSB, it will move to the carry flag. Is it okay?
Yes, sir.
Yes, sir.
Anything you want me to explain over here? Okay. Now let's see how much you understood. Okay, let me have someone now. Okay, kake dakbo? Wait, let me see. Okay, 93. Abir, are you there? Abir.
স্যার ইন্টারনেটের সমস্যা নেই স্যার।
আচ্ছা ওকে অল রাইট। সো রবিউল আসিস?
হ্যাঁ আসি
16 ব্যাচ 147 বলে কি আছে নাকি রে?
আছে ও যে
ওকে আছে
না ও সম্ভবত। আচ্ছা 35, তুমি বলো কি ওর অবস্থা?
স্যার ওর সমস্যা ছিল স্যার, ও বাসায় ছিল তো স্যার, তো ওর বাসা স্যার একদম বর্ডারের ধারে, ওখানে স্যার কি ইন্টারনেট কানেকশন স্যার খুবই রেয়ার আর কি, আর কি ক্লাস করা সম্ভব হচ্ছে না।
আচ্ছা আচ্ছা আচ্ছা, ওকে 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 ওকে।
ও পরে হেড স্যারের কাছে সমস্ত অ্যাপ্লিকেশন দিছিল, তো সমস্ত 35 ওদেরকে রেকর্ডিং পাঠিয়ে দাও, তাই তো?
জি স্যার, জি স্যার।
আচ্ছা আচ্ছা, ওকে 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 ওকে। মানে আমার ইয়াতে আছে তো, ওরে কখনো দেখি নাই আর কি, ওই জন্য জিজ্ঞেস করলাম। আচ্ছা, তাহলে 16 also আকিব?
Yes, sir.
Okay, so help me solve this one, okay? So the question is DH contains 8AH, so this is the binary form of 8AH. This is what your DH contains. Initially your carry flag is 1 and CL contains 3. That means there will be total 3 rotate carry right. I mean 3 shifts, okay?
Yes, sir.
So, or 3 rotates. Actually, we should say rotate, not shift. Shift was a different thing. Now we should say rotate, okay? So after the first rotate, tell me, what will be the value of carry flag?
Sir, 0.
Are you sure?
Yes, sir. If it rotates, then the 0 will be rotated to carry flag.
Okay, so it will be 0. And what will be the value of DH? Tell me.
DH will 11000101.
11000101, right?
Yes, sir.
Okay. After the second rotate, tell me what will happen.
The carry flag will be 1, and DH will be 0110010.
Okay. After the third rotate,
wait a second. After third rotate, carry flag will be 0 again.
okay. Then
I lost the track. Carry flag will be 0 again, and it will be 1011000001.
okay. Now let's check. So the first answer you gave is right. The second one you gave is also correct. The third one you gave is also correct. So the final answer is your DH will contain B1H. I mean, if you convert this one to hexa, you will get B1H and your carry flag will be 0, right?
Yes, sir.
আচ্ছা, কাকে জানি জিজ্ঞেস করলাম আইডি কত ছিল? 16 না?
Yes, sir.
আকিব, right?
Yes, sir.
Okay. All right. So is this example understood to everyone?
Yes, sir.
Sir.
Any confusion, anyone?
No,
No, sir.
Okay. So let's move forward. Oh, we are done. আর কিছু নাই, শেষ? Okay. আর দুটো এক্সাম্পল আছে তোমাদের, সরি, in your book there are 2 small examples, reversing a bit pattern and binary and hex input output. I mean, these are the same thing, the application of your shift and rotate. So then you have your tasks and all, and that is then. Okay, so if you have any question today's lab, please ask. If there is anything at all you want to ask. অনেক বড় বড় ল্যাবের পর আজকের ল্যাবটা একটু ছোট।
থ্যাংক ইউ স্যার।
বুঝছো নাকি সেটা বলো।
স্যার জ্বর নিয়ে কিছু একটা বলতে চাইছিলাম স্যার।
Right. Okay, so the thing is why we did all these things. So you see, let me get back a little bit. Okay, whenever you see instructions like this, that rotate carry or rotate left or shift left, you understood one thing, that these instructions perform directly on your bits, right? So your bitwise operation is always faster than your rest of the instructions, because your rest of the instructions, they need to convert everything, and I mean a lot of conversions are going on. But if you perform your shift, rotate and masking, all these directly affect your bit, so your code becomes more efficient. Like there are more ways to multiply and divide, but if you perform your shift instruction for rotate, I mean for multiplication and division, then your code becomes more efficient. This is what actually I wanted to say. Is it okay? And the reason is also very obvious, because these instructions directly operate on the bits. Is it understood now?
Yes, sir.
So this was the, I mean, main thing why you need all this rotate, shift, then masking and all these things, and why XOR AX. When you move try to remember, for moving you have a lot of complications, like it will go over there, it will go over there, then it will be stored, right? A lot of things are there. But when you're performing XOR, it directly performs your bitwise operation, so it becomes much more efficient than moving. Is it okay?
Yes, sir.
So this was the main reason we needed all these things. Okay, any
Thank you,
other
sir.
question? Any other question, anyone? রবিউল আসিস কিছু বলবি?
জাস্ট আমি অ্যাটেন্ডেন্সটা নিব আর কি।
নে আমার সাইড থেকে এই পর্যন্ত, যদি কারো কোনো কোশ্চেন না থাকে তাহলে তুই এখন শেষ করে দে আর কি।
ওকে ওকে। Okay, 35.
Yes, sir.
16. Okay. Then 09, 17 batch.
Yes, sir.
09.
Yes, sir.
13.
Yes, sir.
16. 16. Absent. Akib তো একটু আগে কোশ্চেন করলো ওকে মনে হয়। 16. Okay.
Yes, sir.
Maybe he is here. Okay. 33.
33 net problem, sir. Internet problem.
Okay. 34.
Yes, sir.
33 কি ক্লাসে ছিল না নাকি?
না স্যার, ওর বাসায় স্যার ইন্টারনেট নেই গতকালকে রাতে থেকে স্যার।
Okay. Then 48. Only 48.
Yes, sir. Present, sir.
Then 88. 89. Yes, 89 is present. Then 91.
Yes, sir.
Is present. 92.
Yes, sir.
93.
Sir, ও নেট চলে গেছে, ইনফর্ম করছি স্যার।
আচ্ছা 98.
স্যার ও আপনাকে মেল করেছিল নেক্সট A2 এর সাথে ল্যাব করবে।
হ্যাঁ। Okay. Sorry. Then 99 also. Then 103.
Yes, sir.
109.
Yes, sir.
115.
Yes, sir.
118.
Present, sir.
Then 138. Sorry, 134. 134. Absent. 138.
স্যার 138 এর নেট চলে গেছে, ইনফর্ম করছে আমাকে।
ছিল ক্লাসে ছিল?
Yes, sir. Yes, sir.
141 তো নাই। Then 144. 145.
Yes, sir.
Then 149.
Yes, sir.
Then 155.
Yes, sir.
179.
Yes, sir.
Okay, let me call again. 99. 134. 141. আচ্ছা কি বলে, সাদমান চলে গেছো? সাদমান আবিদ, সিআর।
স্যার ও অ্যাপস মানে নেট চলে গেছে, আমাকে ইনফর্ম করছে, আপনাকে জানাইতে বলবো 93।
হ্যাঁ, আচ্ছা ওকে একটা জিনিস তুমি তাহলে জানাইও, এই যে 141 এবং অলসো 99 was not present last class and 141 চারটা ক্লাস মিস দিয়ে ফেলছে। তো ওকে আমার সাথে কথা বলতে বলো, অথবা কি সমস্যা আমাকে জানাই। ওকে
জি স্যার।
Sir,
হ্যাঁ
134 messaged in the chat box.
134 তো কই, আমি তো মেসেজ পাইলাম না। ও 144 is present. Okay, 144 34 তো না, 44।
Sir, 34 ও মেসেজ দিয়েছিল স্যার। স্যার, I am in a village so I may get disconnected from time to time.
ও আচ্ছা,
এটা 134 স্যার। 134।
হ্যাঁ, ওকে I got it. So 99 and 141, these two are missing. Okay, thank you. Assalamu alaikum.
Assalamu alaikum.
Assalamu alaikum, sir.
Alaikum salam.